No questions for Kasai? Go on, Jan.
Hello, my name is Jan George. I'm from Internet Society. And as I'm holding the IPv6 topic inside the Internet Society, you said that all these IPv6 goals are achievable, but I would really like to learn where the region is in the IPv6 implementation activities. What are you working on, and what is the strategy time-wise? Because the strategy of using NAT to delay the inevitable is a possible strategy, but I would really like to learn where the region is with implementation of IPv6. Thank you.
Although there is interest in IPv6 adoption, it is obviously slow. And the way to handle this is to have a collaboration between the market structure itself, whether regulators, service providers, or stakeholders, or end users. I recall, for example, in the EU, at a point, they set up a goal that we need to have a 25% of IPv6 adoption across the EU region. I don't know whether that was achieved or not, but we need to set a target like that. Well, a more realistic target, not necessarily 25%, but we can say in this time period, if we reach 5% or 10, and then we move to that level. I guess this is the right approach. But currently it's slow, and currently we are mostly in NATing, and mostly using, as I mentioned, the president, an exhausted resource. It is an exhausted resource.
Yeah, thank you very much. If Mohammed Al-Bashir from ICT Qatar. I'd like just to also, as a follow-up, comment to the question. I think there's some work currently being done on IPv6 because government regulators started to identify IPv6 as an important migration and step to move ahead. For example, in Qatar, we're publishing a national IPv6 strategy, as well. There's a national IPv6 implementation plan that will be agreed with stakeholders soon. In Oman as well, they have a task force, IPv6 task force in Oman is very active. In UAE, they also have a task force, and I think they also working. So there's a push from government and regulator. But I think the operators are the key stakeholder to facilitate things. Some operators see their current IPv4 pool is sufficient and see nothing as the solution for them. Unfortunately, it's not a good strategy, but yeah, I think it's also the business by pushing the operators as well, and from the demand side, that might be a workable solution, maybe.
Hello, I'm Ali Shumali from Zain, Kuwait. Just to reflect on the IPv6 question. Currently, all the operators are considering an IPv6 strategy. It might not be government mandated, but let's say the explosion in 4G traffic from we once started, NAT is no longer sufficient. Speaking on behalf of Zain is actively migrating to IPv6 as we speak, and we have a very key strategy how to move to V6 within the next year.
May I ask what is your target? Do you have a specific target?
Yeah, I can't share with you, sorry. But by hopefully next year, but we did a comprehensive study of the handsets, the devices on our network, And that's what's guiding us towards our V6 strategy. And also there's a question of security to also be addressed, to be honest. Once you remove the NAT, there's a lot of nasty things that can happen to the handsets. So this is something we're also looking into and considering, and we're actively engaging in this matter.
Happy to hear that, and all what I hope is that when we read the next RIPE NCC annual report, we will see a higher graph for IPv6 in the region, and I hope we'll see it in Kuwait also. Happy to hear that.
Okay.
Thank you.
So, thank you very much to our keynote speaker. Thank you very much. So I've kind of ended up in this dual role of leading the conference as well as giving one of the presentations. So the MENOG program committee worked for, I think, several weeks to try and persuade me to actually present about some of my experiences over the last 20 years of internet development and what I'd learned and, well, without making it too self-indulgent, what I'd really been up to. And I don't know, I've always been struggling to think, well, why this would be interesting to anybody at all. I mean, it makes a nice story when I'm trying to give an example during any of the workshops or the training that I've been doing over the years. But I think a few people had heard a lot of these stories and was like, well, can you not just join all these into some kind of slide set and maybe share it with a wider community? So I've tried to put something together. I'm hoping that this is going to be useful. It's certainly been very, very useful for a lot of the experiences and the workshops and training and so forth that I've been helping internet operators with over the years. So where did this all start? Well, I got involved in the internet really in about 1989. I think I was the typical student that got sidetracked by this internet thing. It really started when I was completing my PhD in physics when I was at university. I suppose it even started before then, 1987, 88. Because we had a Unix system in our lab which did a lot of the processing work that I had to do for my research. And of course, being a Unix system, it had things like TCP/IP in it. And that was still pretty new then. It had an Ethernet port on the back of it, and it was kind of, well, what do you do with all this stuff? And so, yes, I got a little bit sidetracked playing around with all the early versions of TCP/IP. I got my own Class C address from some chap in the US whose name don't really remember anymore. But that type of thing really got me very, very interested in how all this network piece worked. So much so that when the engineering department decided that a new TCP/IP network was required, that I should help setting all this up. And I joyfully did all that with all the old technology. You remember the thick Ethernet? The cables were about this big and they were yellow and you could only tap into them at certain points. We did all that. And then it just got more and more involved in the day-to-day operations. So much so by the end of my postdoc, I became really the computing officer for the combined engineering and physics department, looking after the computer-aided design lab and a lot of the department public Unix servers. So it all kind of grew like that. So I knew a little bit about bridges, and there was this scary thing called a router that our department had, and I kind of worked out how that functioned and so forth. So I'd very much caught the internet bug. It's kind of fortuitous because that was the time the UK was going through the whole cutting back of research money. The Science and Engineering Research Council at the time had really, really massive budget cutbacks, and there wasn't really any more money for me to carry on doing my postdoc. So that was kind of lucky. And so the job choice really, when it came to the end of the postdoc, was become a university lecturer or join the commercial world. And I still remember my head of department trying to persuade me that the commercial world was a really bad place to be in because there were things like targets and competitive pressures and, well, the university is nice and comfortable and you can come in every day and you can do a bit of this and a bit of that. So it was a very, very persuasive argument because, you know, I'd been used to the student life and it was, you know, no real deadlines or anything like that, apart from having to do a PhD, which was pretty serious deadline in those days. But, you know, I chose the latter, take a bit of a plunge. And it was quite interesting. It was a few months earlier, I'd finally managed to compile a Usenet News. Anybody remember that, Usenet News? I'd managed to compile the software on my HP workstation. I was delighted. I was one of the first people who'd ever managed to do it because it was written for Sun. And we got the Usenet news feed from the computing center, who'd got one from Edinburgh University, and started looking for jobs. And there, UK.jobs, this ISP was advertising. This ISP called Pipex, looking for a network engineer. So, well, give it a go. I managed to do the department networks. Surely an ISP can't be much different. For some reason, they gave me a job. So started there in 1993. And the first task was, well, first big task was really, well, we've got all these dial-up customers and we've got all these modems scattered all over the room and we've got this new rack. Can you just do the upgrade? You know, just swap them out. So it was pretty much something like this. You know, it's taking all these standalone modems and we remember that, okay, it's a US robotics, but it was a Miracom, is what it was before. Swapping this in and swapping it out. So me being complete physicist, just, well, I don't know, it was a very good example for a physicist. I was being completely practical. So, okay, they said swap out. So took all the Miracom standalones out and put the rack in, plugged it all in, yep, done. Did you test? Well, yeah, I tested, made sure that my modem talked to the rack and it all worked fine. Well, what actually we found out that this was really, really early V32 BIS. It only just come out. And of course, Miracom's V32 BIS didn't work awfully well with anybody else's V32 BIS. And what we found also that other people's V32 didn't work awfully well with the V32 BIS. So yes, it was my first real lesson of do a lot of testing first. Don't just try your modem in the same office using the office PABX. Actually, go home and try different modems and make sure you can still dial in. But it was a very easy way of finding out that vendors' promises and specification sheets often didn't completely match reality. Because V32 BIS, if you look back at the ITU specs, the V32 BIS was very, very early. And V32 was still to the fore. And there's still this early 14.4 kilobits per second and so forth. But that kind of had me on the guard. See, coming from university, you don't really realize that marketing literature is not 100% accurate, that it's actually marketing literature as opposed to the real facts. So that was, yes, as I said there, wishing to be back at university because, oh, university was so good because you didn't have to worry about this. So that was really the first lesson. And then, well, the next one that still sticks with me even today in all the training I'm now doing, in those days, BGP is only for experts. You don't want to touch it. You might break the internet. So I just watched as the BGP expert in our organization did all the BGP bit and cursed about the protocol and about Cisco and Wellfleet and all these people. I learned a little bit about IGRP and how that worked and BGP version 3. If you know your BGP version numbers, yes, in 93, it was version 3. It was fully classful. BGP version 4 only came out in 1994. So I knew a little bit about it, what it could do, and the fact that it could break the internet. So that was my introduction to BGP. April 1994 saw the migration from classful to classless BGP. I mean, that was when it happened for us. We had Cisco beta software. I mean, nowadays, you look at your business and you say, I'm only going to run mainline, well tested. I'm not going to put beta software on my network at all. That's the guiding principle today. Back then, it was all beta software. It was pretty much Cisco would spin another version of iOS that you would download and put on your router. Generally, if you went to something like an Internet Engineering Task Force meeting, you'd meet Tony Lee and folks like that, and they say, oh yeah, I'll fix this for you. And they'd log in, do it, give you an image there and then. And you would run that in production. Nobody would do that these days. But that's the sort of thing we did. So an early beta Cisco software had BGP version 4 in it. UUNet were using it in the US. They were pretty happy, well, as happy as they could be at the time. And so that was our motivation to switch over from BGP version 3 to version 4. And again, I remember those days, my boss came in and it was like, big day today, Philip, the internet could break or not. And it was literally just changing the version number in BGP. And of course, the difference between the two protocols was that version 3 assumed classful routing. Version 4, you had to include the net mask with everything that you announced. And so all that we really had to do was announce our aggregate. That was the brand new change that could break everything. And of course, it all just worked, and there was no real issue at all. So I was kind of getting a little bit suspicious about this BGP could break the internet and so forth, because we found the whole internet didn't break. And most of the internet, at least as far as I was aware, had migrated to classless routing by the end of 1994. So really 1994 was the big swap over from classful to classless. But of course, the classful days had left a lot of a mess behind. There were still large numbers of Class Cs being announced, because up to then, people were getting Class As, Class Bs, Class Cs. And when the internet had run out of Class Bs, or was getting close to running out, ISPs got chunks of Class Cs, which they announced like that, like 32 Class Cs. So there was all this pressure from, well, the CIDR report, which Tony Bates had started about that time, to try and get people to aggregate these Class Cs into, say, /20s, 19s, 18s, and so forth. So that was the CIDR report, and as you hear later on, I think I'm talking again today, is the CIDR report has grown into something way more than the early efforts to get people to aggregate their announcements. And of course, the other thing was, and I've still got the scars on the back of my hands, upgrading those AGSs and AGS pluses from 4 meg to 16 meg of RAM just to accommodate the routing table growth. If you look back on the CIDR report graph, off to the left-hand side, where it was going up like this, I mean, it was going up much steeper then than it is now. The router vendors made buckets of money out of, I don't remember the price. I mean, Nigel will be around at that time as well. It was some silly amount of money, like £10,000 or something, just to upgrade from 4 meg to 16 meg of RAM. And you got virtually nothing as a trade-in credit. But I mean, those routers were really agricultural, opening the cover and pulling the fronts off, and they're all sharp edges and so forth. So I still have the scars on my hands from dealing with those boxes. But I still like them in some ways. Of course, the ISP in 2013 has never had it so good, because in 1994, 95, IGP was fully meshed. No such thing as a route reflector or confederation. Routers at 60 meg of RAM these days, 4 gig, 8 gig, 16 gig, depends who your favorite vendor is. Customer BGP announcements could only be changed during maintenance outages. So my alarm clock was set 4 a.m. Tuesday morning to clear BGP so that our customers could get announced to the internet. These days, we've got route refresh and all the rest. BGP table took most of the available RAM in a router. I still remember, 200K free. And then Cisco came up with this, oh, well, you need like 20% free, otherwise the table fragments. Well, sorry, 60 meg of RAM, 200K free, please tell us what you can do. And so there's very, very big pressure at the time for aggregation and not overdoing the routing table. Sean Duran in those days at Sprint did great service for the internet by really having some aggressive filtering for his customers and peers and so forth. It's just a shame that no operator will take the same aggressive stance as he did, but they probably couldn't get away with it in the same way that Sean could back then. And of course, people still don't understand what IGPs were for, IBGP, eBGP, and all the rest. We didn't have anything like BGP communities and so forth. But there were improvements. I think, again, in those years, 94 through 99, were the major improvements that we see to BGP today. If you look in, say, the last 10 years, very few things have been changed in BGP. A few tweaks here and there, but nothing like the big changes we saw from 94 to 99, right? BGP was still fully meshed, overloaded CPUs, and that meant a major US ISP backbone melted down. I think it was like 65 routers. They added the 66th iBGP fell over. And it wasn't just a case of removing one router and it all came back. They had to shut off, I don't know, a third of the network, something like that, to get the mesh back. So BGP confederations was the quick hack that came in to fix that. And so you see some of the ISPs from back those days, 95, well, late 94, early 95, and now have a confederation set up. Whereas a year later, IETF got involved, route reflectors, and that's pretty much what the rest of the world are using to scale their BGP today. Of course, you know, I was young and foolish then, and we thought, oh, route reflectors, great. And so we just migrated our whole network in one 2-hour maintenance slot. That was crazy. I mean, I'd never ever done a route reflector before. I was just going by Cisco's manual. And you'd think I would have learned from the Miracom experience, but oh, no, we just did in one 2-hour maintenance slot. We were very lucky that it all just worked. It all just worked. But you know, certainly nowadays, I would never, ever recommend anybody just converting their whole network from full mesh to route reflector in one 2-hour maintenance slot. So that was the second lesson. Testing, planning, testing, and phase it properly. Don't just plunge straight all in. I suppose those are the early days, young and foolish. Now, Kasai mentioned internet exchange points. So this is our experience, and Nigel will probably recognize half of this as well. Peering with the enemy. So this was, well, it wasn't the enemy as such, but that's the way our salespeople presented it. When they found out that we were talking about an exchange point, it was like, you've got to be out of your mind. You've got to be crazy. We had our own paid capacity to the US, cost a small fortune. We had paid connections to eBone. I think it was like a 2 meg link to eBone, cost even more than the link to the US. And we got the European routes, which were not very many, at least not enough. And then we also had SwipNet, which was one of the ISPs in Sweden. These were very, very expensive links. So we had all the amusing things of, well, we were in Cambridge in the UK, if you know the geography. One of our competition hosted, I think it was the Sun website for Sun OS, Solaris, and so forth, 3 doors down the road. Trace route between the two went via the west coast of the US. This wasn't very good. It was actually faster to get a tape, go down the street, and get the update than it was to try and FTP it. So interconnecting with the UK competition, who in those days were UKNet, Demon, and BTNet, was pretty much considered selling the family jewels. The sales folks were really unimpressed because it would just kill the sales growth, they would lose business, and we'll go out of business, and it'll be the end of it. And it's interesting, you know, this is, what, 20 years ago, 19 years ago. I've been involved in setting up so many exchange points over the years, and this is the first argument I hear every single time. And I say, but look at links now. Ah, yeah, but that's different, you don't understand. Ah, well, I do understand. All the arguments are RTT, round trip time, quality of service, customer complaints, the extreme cost of international bandwidth, logic, common sense said it's the best thing to interconnect to your competitors. We did have a link to Janet, which was a UK academic network, because they had lots of useful things like FTP sites and Archie. Anybody remember Archie? They had all that. And so we had to connect there because our customers wanted access to some of that stuff. So that was the birth of links. Logic, common sense, RTT, QoS, finances prevailed over the sales folks' fear campaign. And it was actually the technical leadership of the 5 operators met. It wasn't left to the big bosses. Actually, the big bosses and some of these were involved. It was very much the technical folks were involved in this and agreed the exchange point was needed. We looked at SE gigs, you know, the Swedish, the D gigs there in Sweden, and that was already operating. And there were 3 Swedish ISPs, all quite happily interconnecting, and it was all working. Of course, you know, again, one of the things I remember was each ISP wanted to host it. You know, I don't think we particularly cared, but UKNet definitely had to be in Canterbury. Demon wanted in their offices somewhere in London. BT said, oh, well, you know, we've got this great place in central London. Janet, well, you know, let's put it at, where was it? Was it UCL? I don't remember. It was one of the universities in London. Let's put it there. And we actually suggested, somebody suggested it goes into Telehouse, and that's a recent picture of it, but that's pretty much the building, which is in the East End of London. Telehouse is another story. It was a financial disaster recovery center. It was absolutely nothing to do with internet at all. I remember some of the early meetings with the European directors at Telehouse, and they said, we want to put a point of presence in here for internet. And like, internet? What on earth's that? They took a lot of persuading that they should host an internet organization. Well, they wanted a couple of racks. We needed somewhere else to put a data center in London because the one that we did have had very, very difficult access in all senses. But they were disaster recovery for the City of London financial markets. They had complete replicas of all the trading floors and everything else. And so the early Telehouse was trading floors in a tiny data center. And those of you who are in and out of Telehouse today, whichever building, you know it's just like data center wall to wall. And pretty much it was the turning up of links at Telehouse that converted Telehouse from being a financial disaster recovery to the business they have today. They should remember that. So success, we got the UK peering going. Links was established in Telehouse London, 5 operators, 4 commercial, 1 academic. The first fabric, now this is funny, was an Ethernet hub. I'm not joking, it's an Ethernet hub. We had, in Cambridge, we'd literally taken the hub out of our POP because it was starting to lose packets at about 3 megabits per second, so we bought one of the early Cisco Catalyst 1201 switches. I found this picture on the net. I was quite impressed. I managed to find one. But if you've ever been to the Science Museum in London, the link switch is there. I've never touched and used stuff that's ended up in a museum, but now I have, and that's a bit frightening. Anyway, so we got the Pipex Ethernet hub went into the link. So there were 2 hubs. They started losing packets at about 3 megabits per second. So then a 1201 switch went in, and as more providers came, a second catalyst went in there. I think we connected them together by FIDI or something. Third lesson, peering is vital to the success of the internet. And what was ironic, the sales took off. I mean, it wasn't like doom and gloom, because the argument, of course, to any folks worried about loss of business is, think of all the potential business that you can make, because your customers are now all having very, very fast, unrestricted connections between each other. Right? Customer complaints about round trip times and QoS all disappeared. And in fact, we found that traffic across the exchange point was comparable to our US traffic. So links was actually critical in creating the UK internet economy. I mean, this is just some of the examples. Microsoft data center was UK-based, much to the annoyance of UUNet in the US, who thought they had the global contract. But actually, Microsoft said, well, we'll go into London. There's a links there. And they got connectivity to the links via ourselves and BTnet. What our sales guys didn't like was we lost all our resellers, because our resellers no longer needed to get transit from us directly. They could all go to links and interconnect. So they peered at links, they bought their own international transit and so forth. And you found that there were smaller ISPs, international operators, and the content providers turned up. I mean, there were a few rule changes that links needed first, but that was by and large what had all happened. Peering is vital to the success of the internet. Interior gateway protocols, well, IGRP was Cisco's classical interior gateway protocol. Migration to EIGRP was pretty simple. But then the next one I did was my next foolish mistake. Well, not really a mistake, but yeah, well, EIGRP is Cisco proprietary, and well, we've got other equipment that's not made by Cisco. We need to run something that other vendors will support too. So let's move to OSPF. So practically it's easy because the protocols have different priorities. But in reality, it wasn't quite so straightforward. Because OSPF has a higher distance than EIGRP, you can deploy OSPF and the network will still keep running. What you should not do is once you've deployed OSPF is just yank out EIGRP and hope that everything works. So that's what I did. We did this all over a weekend. We turned up on Monday and the customers were phoning in like crazy because almost nothing really worked. Fourth lesson, migration to an IGP needs to be done for a very good reason, with a documented plan. We didn't have anything like that. I suppose, again, young and foolish. Backout plan, leave the old one running, just in case the new one doesn't work very well. What it actually resulted was we moved from ERGRP, which was a working, scalable IGP, although it was proprietary, to OSPF, which was really going through its worst phases as far as Cisco was going, because it was so many bugs, so many things had been added to it. The OSPF rewrite that Cisco was doing was still half a decade away. They did a rewrite in 2003. So this was still a long time away. And of course, UUNet then had a closer relationship, were very close to buying us. And of course, they were using ISIS. And when they found out we moved to OSPF, it was like, are you guys out of your mind? So, and the reason, of course, for ISIS, I mean, we're looking back to like 1996. The reason for ISIS back then was, well, don't really know. It's a bit peculiar. Only Sprint, UUNet, and one or two others were using it. But of course, these days, it's now a protocol-independent routing protocol. And what I'm finding is that most ISPs who are deploying V6 are abandoning OSPF in favor of ISIS because ISIS is carrying both V4 and V6 address families at the same time. So, you know, it's another learning lesson. Redundancy. This one's hilarious as well. We had two links from the UK to the US, Cambridge to Washington, London to New York, running on separate undersea cables. Well, that's what British Telecom told us. That's what Cable and Wireless told us. And it's a long story about guarantees, maintenance, undersea volcanoes, cable breaks, and so forth. I mean, I don't really want to go through those. There were so many of them. You know, being the network engineer, being responsible ultimately for the UK infrastructure, being the last point of call and so forth, you find out all the different tales. But the fifth lesson was make sure that critical international fiber paths are actually fully redundant. Don't just listen to what the providers actually say. It's important that they don't cross or touch anywhere. I mean, and literally cross or touch anywhere. If they're going through the same conduit, they're touching. Because, you know, there's so many issues of, yes, it's independent fiber, they're not touching, but they're going through the same duct out of, say, Telehouse, or they go from alongside the same train line between, what was it? I've forgotten, somewhere in Bristol. And the train came off the tracks and cut the whole thing. So it's stuff like that you really need to be aware of. Also, make sure they're restored after maintenance. We had a classic case of maintenance on, what was it, TAT 11, and we got diverted on to PTAT or something, was one of the cables across the Atlantic, where our other circuit already was. We never got moved back, and so when there was a major outage in the Atlantic, I think a volcano in the mid-Atlantic ridge erupted, well, we lost both cables, and we had both British Telecom and Cable and Wireless into the office, said, right, how come both broke when they're meant to be about 5,000 kilometers apart? Ooh, well, it's probably your equipment. And it actually turned out, after a lot of, well, threats and so forth, that they actually had forgotten to move our circuit back onto the cable it was meant to be on. What else? Aggregate origination. Given I've got 10 minutes left, I mean, there's so many issues here. Aggregate origination, generate aggregates within the backbone, not sitting on the Washington router. Well, that's what we kind of did. Bit of a mistake, because when both the transatlantic cables failed, the Washington router was still announcing our address space. We could send packets out, nothing came back. Trying to get somebody in the US to turn off routers on the 5th of July morning is not straightforward. They've all had a very good night the night before. Sixth lesson, originate aggregates in the core. How reliable is redundant? Telehouse folks will remember this. When somebody tells you something's 100% reliable, it's probably not. I mean, the building was very, very impressive. You can go there today and you see it. Fiber access in opposite corners, blast-proof windows. They had a moat in the front of it to stop reflection from blasts and so forth. Several levels of access security. I mean, they boasted about the security. The funny thing was, the main security guard was from Aberdeen, where I'm from. And I could just turn up, and I was like, oh, yeah, hello, we'd talk about this, that, and the next thing. Oh, you want back into your usual room? Yep, no problem at all. Nothing. That was it. Easy access. Even after I left Pipex, I was kind of, I bet I could just go in there and get access to any room I wanted. But anyway, they didn't hear that. Yes, 3 weeks of independent diesel power, external power from 2 different power stations, all fine until they did maintenance on the diesel generators. After the maintenance, they switched the wrong circuit. They actually switched off the external power. The whole half the building went off. And of course, they realized the mistake when lights started going out, so they switched everything back on again, and the resulting blew up a lot of the UPSs and a lot of the power supplies and a lot of people's equipment. And of course, it was news headlines on the BBC, UK internet switched off by maintenance error at Telehouse. It didn't actually affect us too badly, because on our bigger routers, we had dual power supplies, and we actually plugged one supply into the UPS, the other one into the dirty mains. That was pure luck that we'd done that. And so even though the in-room UPS had failed, when the external mains power came back, our routers all came back. So once the physical infrastructure got going again, we were okay. But it was really difficult to stop the sales folks from being smug about it. Because like, yeah, we're super redundant network, we had all this, the other guys didn't. But because something else could quite easily happen. 7th lesson, never believe that a totally redundant infrastructure is. 2 of everything is really important. And those of you who have been through various tutorials of mine, I say commercial aircraft have 2 engines, at least, for a very good reason. I could mention bandwidth hijack, but I'll jump through this because I'm taking far too much time. I've only got, we want to stop by 11 o'clock for the break, so I'll just jump through this. So the short, sharp shock. It may have only been 5 years from 93 to 97, but those are probably the most compressed learning experiences ever. And those learning experiences have really, for everybody who's gone through it, have really done a lot to contribute to what the internet is today. I mean, the folks I know from those years had to learn so much so quickly, really from having not a lot at all in the early 90s to a very, very fast-growing commercial internet in 1998. And of course, there are a lot more than 8 lessons. I've only given some of the highlights here, but there are a lot of others. So moving onwards, UNet's global business, it became all money, and so forth, and it was time to do something different. So Cisco seemed a good place, joined the consulting engineering group, very much to give the vendor some idea of how ISPs operated the internet, what the ISPs actually required. I mean, this was really the request to come and join and do. And so I thought, yeah, great, I can get all these Cisco iOS bugs fixed, and I can get all these great new router platforms that we need, but they're not actually making for us. Big mistake. Vendors have committees and all the rest to try and figure out what's best for the customer. And so when you actually provide input that's reality, they don't really want to listen because it doesn't line up with roadmaps. So my role instead became very quickly one of infrastructure development. Oh, you helped set up links, you helped do this, you built this ISP, and so on and so forth. Let's try and do it somewhere else in the world. Because the 90s were such formative years, the account teams around the world very quickly realized that this was useful, great way for selling product, and so forth. So working with a colleague, we started off doing these Cisco ISP XP Workshops. And we have the kit there. That crate traveled around with me for several years. And it's too dark to see, but that was actually one of the first workshops I did with the UNDP in Kuala Lumpur. But we taught a lot of things like IGP, BGP design, best practices, a lot of the new features. A lot of people still hadn't realized what the new features were. Covered the ISP network, covered what an exchange point was about, and encouraged the formation of the IXs, introducing latest security best current practices, and the early introduction to V6. I actually had deployed V6 in UUNet with colleagues in 1996, late 96, 97. So I should have worn my V6 t-shirt that said, been there, done that. But it was that long ago. We got some early Cisco beta software and played with V6 then. So V6 for me is kind of boring because I've been around it so long. But out of that came all this infrastructure development and support from around the world. So there are lots of them. I could talk for probably half the morning going through a lot of the experiences from these. But the most special one for me is this one. This was pretty much the last country in the world to get internet access. So in 1998, the fourth king decided that internet should be available in the country for the 25th anniversary of his coronation. So 2nd of June 1999, so staff from the ISP came to that workshop in 98, and in March I got the phone call, the email saying, help, help, please come, we need to get this ISP set up, and we've got 3 months to do it. And the king has asked for it. So you can't really refuse this type of thing. And of course it was one of the, it's the modern Shangri-La. Nobody really goes there, it's hard to get in and so forth. It was pretty frantic activity, but that was the email. Please come, with a warning that there was no air conditioning in Bhutan. So given this email was in March when it's kind of almost not snowing, I don't know what the air conditioning was about, but anyway. But yeah, beautiful place, and it was a frantic activity. I found this was the network diagram that I had proposed, and you look at it and you think, gosh, why would you do something like this? It was a bag of bits. The UNDP program had ordered 1 or 2 bits and pieces of devices in, so I really had to try and make best effort of what was there. So 99, it does look messy. We used whatever equipment was already there. 2511, IBM AIX, anybody remember that? Those were the servers that the UN had ordered. I was like, you've got to be joking. We were using Linux and so forth. And AIX, you couldn't compile anything on it. Anyway, so we made something work. You can almost see the picture on the right there. But we designed and built it as an ISP, whereas the previous effort really much was, let's set up an internet cafe. This is not a cafe. You don't have a cafe to run a country. If you look at it today, 2.5 gigabits to London, 2.5 gigabits to Hong Kong, 1 gig to Chennai. They have national dual-stack backbone. We rolled out V6 and for them. When did we do it? 2005, 2006? It's all redundant fiber, radio links. POP is all dub 2 of everything. Wide rollout of broadband and mobile data access. Coverage in most districts of the country, even though there are very few roads. A lot of the districts are 3-4 days walk, yet they have internet. The 3 competing ISPs, but there's still no internet exchange points, something I keep having to want to fix. What else? Well, there's Nepal's exchange point. I'll mention this one quickly. Again, there's several ISPs, no interconnection. And so the location was easy. Find a tall building. So if you go into Kathmandu, you'll understand. The buildings aren't very high. They looked for the tallest one, so they can actually get wireless access in there. So after the first SANOG meeting, SANOG is the South Asia Network Operators Group. NPX was launched, established, put in the switch, initial connections. Of course, the National Telecom refused to participate. And there was a bit of hand-wringing, we want everybody in the IX, otherwise blah, blah, blah. But actually, it doesn't matter. The independent ISPs all wanted to interconnect anyway. So they refused. And so the independents carried on anyway. And there were a lot of problems about wireless interference using 802.11, which is unlicensed, and everybody was trying to use it. And you just turn up the volume to try and drown out everybody else. We did a BGP workshop, of course, but people didn't really have much idea about routing. Or routing knowledge was really limited. So it was quite entertaining. Spent a week with Garab, who used to be a member of the MENOG core team, driving around Kathmandu. A lot of time in traffic jams, breathing diesel fumes, getting AS numbers from APIA, deploying BGP, as well as a whole heap of other things. It was really almost build the internet with several of the ISPs and get all the peering going. Today, Nepal Telecom has joined because they realized that they were losing out. All the other ISPs were well interconnected, the telecom with a lot of students and so forth, getting lots of complaints. The exchange point, 300 megabits per second, given the country, that's pretty impressive. It's a small country, but 300 megabits per second traffic. Here's another one. This is the exchange point picture for Bangladesh, for the BDIX. There's still, many countries around the world don't have anything at all. Some are too small, but others are bigger, and the quality of internet and of the internet access is very, very low. I've spent a lot of time over the years helping deploy exchange points in Africa and so on and so forth. Vanuatu, for goodness sake, they have just set up the Vanuatu Internet Exchange. If they can justify an exchange point and see the benefits, virtually everybody else can justify it as well. Do you have time for the Mongolia story? Yeah, 2 minutes. This one's good. Right, I had a long association with the Mongolian industry, internet industry. So this was the first workshop I did in 2005. Shipping equipment, Miat, the airline, Boeing 737. The workshop kit box, this too big to fit into the hold. So it had to go on Korean Airlines and all the rest. So getting the kit there was a story in itself. But there was this issue, disappearing internet. I got the request to do the workshop because the internet in Mongolia was slowly disappearing. BGP was set up, 2000, by an engineer flown in by Cisco, all very well done, but they were experiencing problems. Customer complaints, BBC and CNN and other content websites were slowly disappearing. They couldn't get access. Well, geography, Mongolia is sandwiched between Russia and China. So transit through those countries all by satellite. So see the picture? So they were suspicious that the Great Firewall of China was to blame. Because, BBC, CNN, you can't really get access. You only get access to certain bits in China. Anything that's critical, you don't get access to. So they thought that they were falling foul of this. They were convinced of it, because there's not really much love lost between the two countries. The upstream denied it, of course. They said they got clear channel. So it seemed really unlikely. I mean, it's a nice story, but rather unlikely. And what was happening between 2000 and 2005 was that the registries were distributing new address space. There was a significant growth of the content distribution networks. The BBC wasn't just in London. They were setting up data centers all around the world with new address space, as was CNN, as were everybody else. So the new content networks were using new address space. The disappearing internet was caused by BGP filters put in place in 2000. These were the don't touch BGP, you'll break the internet rules. So they had static routes, filters, blocking all the unused address space. So you go to the IANA website, all the unused address space was in there as a filter, blocking everything. Remove it, the internet became visible. Simple as that. Less or no matter how fantastic a reason for failure might seem, real reason would be more mundane. So the real reason, lesson, don't use static filters to block unused address space, at least without keeping it up to date. And the other lesson, which is really, really important, learn BGP for yourself rather than outsourcing it. It's not really that hard. That's the most important bit. And this has really been a lot of my experience over the years. You can look at the rest of the slide set when it goes on the website. The Ghana one was interesting, the vendor fighting each other. But the story goes on. There have been lots and lots of these different experiences. All these people tell me that I don't understand their situation because it's completely different from everybody else's. Everybody is completely different. The internet is not the same anywhere in the world. There's lots of redesigns, satellites in the Pacific falling out of the sky. That was not much fun. Latency, TCP window versus performance. People don't believe that satellite links have 600 milliseconds round trip times. Fiber optics being stolen, very, very common through South Asia. People think it's copper. They don't know it. They just see a cable. Oh, I'll take a kilometer of it away. Only it's fiber, and you can't do anything with it. North Sea fogs and snow, which block microwave transmission. Hello, cable and wireless. That was, we had endless problems with that in Cambridge, which spends most of its time being foggy. This is a favorite one. Philip, you don't understand. And this is the best of them all. You cannot change the laws of physics. To operators and end users who complain about round trip times. Why does it take 100 milliseconds to get from London to New York? Can you not make it go faster? The amount of emails that we got for that type of thing. And if you actually work it out, the speed of light, it's about 60 milliseconds for the speed of light just to get to London and to New York and back. So by the time you think of equipment and everything else in between, anyway. So that's it. That's been, well, a sum shot of some of the experiences and so forth. But the fundamental bit here, there are a lot of really interesting lessons. A lot of these lessons learned in the early days of trying to keep an internet operations going. So I hope this is what the PC intended. I hope it was interesting and useful. And if there are any questions, I'm happy to take a question or two. Otherwise, we'll have our half-hour late tea break.
Any questions for Philip?
I don't think there are any questions from experiences. They're just experiences. Please don't ask me to write a book.
You
yes. There's a there's microphone coming, because we're webcast, so the folks online can hear.
Thank you. Yes, how do you used to deal with regulatory in these new countries that they really didn't have any set of rules and laws to govern internet, and how did you contribute to that?
Oh, I mean, it's depended which country. I mean, if I look at, depends who the regulator is. I mean some of the regulator level very much look at the telecom market and try and apply that to the internet market. So it's really been a case of looking at what some of the issues that they're presenting and how they should be dealt with from the telecom side, and then trying to explain how the internet side will function with it. You know, it's trying to think of examples. I mean, I can think of, for example, there's a positive example in Vanuatu that I have, where the regulator was very, very, I think he's very, very switched on to enabling competition in his own marketplace. He's very open to opening the whole system. And so that was an easier conversation to have. In fact, the conversation was almost, I don't know if you want to go that far in making it all completely liberal, and certainly such a small place like that. But it really depends on the circumstance. But it's definitely not a case of walking into a regulator and say, you need to do this, you need to do that, and you can't do this. It's a lot of understanding of the reasoning, understanding of the local conditions, because they may have a very good reason for doing something that they want to try and do. You know, I've had to deal with things like, oh, should we mandate that everybody does V6 and we turn off V4? And you know, the V6 folks will go, yeah, it's a great thing to do, but the practical reality is, well, how do you get access to the old V4 internet while you're doing the V6 deployment? So it has to be a dialogue, it has to be an ongoing conversation to really understand what they're trying to achieve.
Anybody else? Wrap up for coffee then, I guess.
Okay, let's have our coffee break. So shall we start again at 11:30? We'll run half an hour late. We'll start again at 11:30.
Please pick up your t-shirts. They're in the back. Have a chat with our sponsors. And I forgot to mention, if you want to host an Atlas probe, please find Alistair.